So you just purchased a Lionel Lion Chief train set or one of the new Menards train sets, or maybe you're thinking about buying one. The first thing you notice was that these new trains do not use a traditional transformer, but instead use a remote control device. And you're wondering, can I run these remote control trains together with regular transformer controlled trains? Hello again, this is Mike with another episode of Toy Train Tips and Tricks. The most common complaint that I see in online train forums about these new types of trains is that they are not compatible with conventional control trains. But that's not exactly true. As you can see, my Menards Beta 4.5 Santa Fe FP7 with remote control from 2023 operates just fine with my Lionel Chessie U36B from 1974. And I was controlling the speed of both models with my traditional transformer. So how do I perform this sorcery? Well, if you understand how these systems work, it's not sorcery at all. First, let's look at conventional locomotives. From 1900 to the early 1990s, virtually all toy trains work the same way. The locomotive contains a motor. The speed of the motor is controlled by a variable voltage device, generally called a transformer or power pack. The higher the voltage, the faster the motor spins. Most locomotives also contain a direction controlling device, usually called an E-unit or reverse unit, and this is essentially an electromechanical or electronic relay that changes the direction of the motor when power is interrupted from the transformer. The sequence can be either forward, reverse, forward, or forward, neutral, reverse, neutral, forward. Some electronic reverse units automatically reset to forward if the power is off for more than a few seconds. Some conventional locomotives may also have a horn, bell, or whistle function. And again, these actions are controlled by relays, and they rely on an activation signal, a pulse of DC current, from the transformer or an anode control box to operate. So, for conventional locomotives, all functions, speed, reverse, and sound, are fully controlled by the transformer or power pack. The transformer is the brain, so to speak, and the locomotive is the mindless body that follows the commands from the transformer. For Menards or Lion Chief locomotives, things are a little different. The included power pack is a constant voltage supply, generally called a brick or a wall wart. It sends out a constant and continuous stream of electricity, generally between 14 and 18 volts. If you put a conventional locomotive on a track controlled by one of these transformers, it will run away at maximum speed and likely derail at the first curve it encounters. But a Lion Chief or Menards locomotive has an onboard microprocessor, a small computer, so to speak, that acts like a brain to tell the motor what to do. On, off, fast, slow, forward, reverse. The microcontroller also controls any sounds or effects for the locomotive. Horn, bell, whistle, crew talk, whatever. But while the microcontroller is smart, it cannot make decisions for itself. It relies on signals from a wireless remote control to tell it what the operator wants to do. The power pack supplies the power, the remote control gives commands, and the microcontroller gives the commands to the motor and any other functions on the locomotive. If you put a remote-controlled locomotive on a conventional track without its controller, it might light up or make sounds, but it will not move. But Mike, you say, that sounds pretty incompatible. I mean, either one works and the other doesn't, or one works and the other one flies off the track. Well, that's true, but here's the trick. When the microcontroller on a remote locomotive sends a speed signal to the motor, it does not give a specific voltage amount, such as 16.2 volts or 14.1 volts, etc. Instead, it regulates the motor power as a percentage of the available track power. Therefore, if I set my remote control to 100% forward and send 18 volts to the track, the train will run faster than it will if I send 16 volts to the track, or 14 volts, or 12 volts. So, if I use a variable voltage input, like a traditional transformer, I can control the locomotive's speed by using the transformer instead of the remote control. And I can operate and control a conventional and a remote locomotive together on the same train by using the transformer. Just be sure that your transformer voltage does not exceed 18 volts. Some pre-war and early post-war transformers have outputs as high as 24 volts for use with standard gauge motors, so be careful. For this demonstration, I'm using an old Marx transformer that maxes out at a little more than 16 volts, so I have some safety clearance on the top end. So first, let's walk through the process with a single remote-controlled locomotive. First, set your voltage output of your transformer to 0. Place the locomotive on the track, and now set your remote control to maximum voltage in the forward position. If your remote has an on-off switch, of course, make sure that it's set to on. Now, slowly increase the voltage output from the transformer until the locomotive is moving. Voila! You've done it! Now you can control your train's speed using your traditional transformer. You can still use the remote to operate the horn, bell, and other sound functions while controlling the speed with the transformer. You cannot control the locomotive sounds with the transformer's sound control buttons, however. In fact, out of an abundance of caution, I do not recommend using these buttons at all when running a remote-controlled locomotive, even if you have a conventional locomotive on the track at the same time. Well, why? Well, in theory, the rectifier in the microcontroller should handle the DC current the transformer sends to activate the horns and whistles with no problem. In practice, however, we do not know the technical specifications of the board or how robust those components may be. Therefore, I suggest avoiding the problem altogether by not adding this stress to the electrical components. Now let's add more power to our train by adding another locomotive, a traditional, conventional controlled locomotive, and let's operate these diesels together. First, a few caveats. For best results, conventional locomotives should have their reverse units locked in the direction of travel. While it's possible to coordinate a reverse unit cycle and a remote reverse at the same time, it can be quite a handful, especially if you're under stress. You will still have access to all sound and special functions of the remote locomotive by using the remote. Hit that horn button all you want. Obviously, a conventional locomotive is not going to respond to the remote control signals. As before, I do not recommend trying to activate the sounds on the conventional locomotive while paired with a remote locomotive. This trick works best with older pull-more type locomotives rather than with modern can motor engines. The older pull-more motors do little more than hum until track voltage reaches right around 10 volts. By coincidence, the components of modern remote control trains do little more than activate lights below 10 volts. So, both types of motors have roughly the same starting voltage, making it easier to coordinate them. And also, make sure that the combined current of all the motors, lights, and everything else on the circuit do not exceed the output of your transformer. In other words, a small starter set power pack will likely not operate two locomotives simultaneously. To perform this trick, turn off your track power. Next, lock the reverse unit of your conventional locomotive in the desired direction of travel by cycling the reverse unit until you reach the proper direction, and then throw the disabling lever or switch on the unit. Add your remote locomotive to the train with the power off as before. Set the remote direction and speed control to full power, then slowly turn up your transformer voltage until you find that sweet spot where the two locomotives run well together. Now, both locomotives run together with conventional transformer control. But what about command control? Well, Lionel's Lion Chief Plus, TMCC, and Legacy systems, as well as MTH's DCS system, all have built-in accommodations for conventional control. You may lose access to some sounds and special effects, but you can already operate these locomotives with a standard transformer with no modifications at all. So, as you can see, there's no need to fear mixing contemporary Lion Chief or Menards remote-controlled locomotives with traditional transformer-controlled trains. With a simple trick, you can control the speed of both types using a conventional transformer, even multiple locomotives at the same time. And you can confidently add these new remote-controlled locomotives to your traditional toy train layout. So go ahead and take the plunge and add one or more of these nice-running, feature-packed locomotives to your traditional, conventional controlled layout. As always, I hope you enjoyed this video as much as I enjoyed making it, and if so, tell your friends and neighbors, and especially let that YouTube algorithm know by liking this video, subscribing to the channel, or by leaving a comment. And of course, keep the trains running, and we'll catch you next time on Toy Train Tips and Tricks.